Hey guys, today we're killing Chaos Druids. It's the most ambitious bot of the series so far. It's got a detective druid, click on it, wait until it dies, and then pick up any bones and any other things it might have dropped. Right, let's begin. So we're going to start by detecting blobs, which are regions in an image of a certain colour or certain range of colours. And we've seen in previous videos that we use the OpenCV InRange and the Find Contours function to detect these areas. So we're just going to take this code and we're going to put it as an own class so we can call it from multiple places. So this method takes an image, it takes a lower bound and an upper bound, and we're just going to use the InRange function to select the pixels we want. Then we're going to dilate it, which has the effect of taking two blobs that are very close to each other and connecting them so we can detect it as a single blob. Then we're just going to show it out to the screen just to make sure it's working. And we're going to use the Find Contours function to detect these blobs. And just make sure we find any. And we want to find the largest one, so we're going to spin through each blob and just check its area, and if it's larger than any contours that we've already found, we'll just assign it to the largest contour. Then we're just going to return it. So we're going to start with an empty detector for our Chaos Druids, and we're just going to inject in our object detector. Then we can set its debug mode as well and print our image to the screen. If we run that, yep, looks like it's working fine. Next, we're going to convert our image to the HSV color space and use our object detector to find the largest blob. Then we can draw a rectangle around this blob and print it out to the screen. So to find the minimum and maximum bounds for our blobs, we're just going to use the sliders and we're going to slide them until the Chaos Druids disappear. About there. There. Now for saturation. And finally the vibrance. Okay, and we can plug these values into our code. If we run that, then we find some Chaos Druids, and we've got a box around that one. Now it's time to kill the Chaos Druids, so we're going to write a kill bot that takes the detector as the generic argument, and we're going to start by just bringing the game to the front, and now we're going to write a method that just kills a single monster. So we're going to get the detector, and then get its location. If we can't find the monster, we're just going to return. Otherwise, we're going to left click on our monster. And we're just going to sleep for a little bit afterwards. Then in our run method, we're going to loop, we're going to kill a monster, and then we're going to sleep before trying again. If we test that, we see we are clicking Chaos Druids, but it's not waiting for them to die. So the next job is going to be detecting the health bars. To detect health bars, we're just going to start with an empty health bar detector. And we're just going to create a little class to hold our health bar. So it's going to have the location as well as the amount of health left in the bar. And we're just going to have a list at the top to store all the health bars we detected. As far as the detect function goes, we're just going to start by printing out our screenshot just to make sure our test is working. And yep, looks like it is. We've got 2 health bars we need to detect. So we're going to start by detecting all the red pixels. And then all the green pixels as well. Then we're going to take those 2 and we're going to combine them into a single image and print that out to the screen. You'll see we're not converting to the HSV color space here because we're only detecting a single pixel value. So the minimum and maximum are the same. If we run that, you see we found 2 health bars, but we've also detected some text there and some down here as well. Next, we're going to use the find contours function to find the areas of all the blobs in the image. And initialize our list of health bars, and then spin through each health bar and get its bounding box. At this point, we're going to get the ratio of width to height, and if it's not greater than 5, we can continue. That way we should only be detecting health bars. Otherwise we can push it to our list, and let's draw a box around each of our health bars we found. And print it out to the screen. We run that. So we found 2 health bars there, and it's not detected any of the text of health bars. Okay, at the moment we've only detected the location of the health bar, so to detect the health as well, we're just going to have a look at what the green health bar looks like. So if we run that, we can see the health bar is either completely white until we're at the right edge, or it's white and then we get some black pixels. So we're just going to extract the health bar as an image and then just delete that. And then we're going to write a function just to see how many green pixels there are on the health bar. So we're going to start with a pointer to the leftmost pixel, as well as a pointer to the end of the health bar. And we're just going to go through all the pixels in the first row. And if we hit a black pixel, or we hit the end of the bar, then we're just going to return how many pixels along we've gone. Otherwise, we're just going to move to the next pixel. So now we detected how many green pixels there are in the health bar. We can calculate the health by dividing that number by the width of the bar. Now we can modify our killbot, and instead of sleeping after we click on an enemy, we're going to do 2 things. First, we're going to wait until we're under attack, and then we're going to wait until we're not under attack. So to wait until we're under attack, we're just going to get our health bar detector, and we're going to check how many health bars are on the screen. If it finds a health bar, then we can stop. Otherwise, we're just going to sleep for a bit and continue. And waiting until we're not under attack, we're going to do the same, but the other way around. So we're going to get our health bar detector and check the number of health bars on the screen. And if we find any health bars, then we're going to sleep and try again. Otherwise, we can stop. If we run that, you can see we're clicking on the Chaos Druid and we're waiting until the health bars have left the screen before clicking on the next one. And you can see in our console window how many health bars it's detecting. Okay, now it's time to pick up the bones. And to detect where the bones are, we're just going to use our health bar detector again. And we're just going to figure out where the enemy's health bar is. To do that, we're just going to wait until we find a health bar that's got 0 health left in it. Once we've got the enemy health bar, we know the drop location is going to be slightly under that health bar. Now we're just going to right click on that drop and we're going to wait for a little bit. It should bring up the context menu. So let's write a context menu detector. And we're just going to start with an empty detector and print out the screenshot. If we run that, we see we have a context menu we need to detect. So first thing we're going to do is select all the background pixels. It's only a single pixel value, that's not really used anywhere else in the game, so we don't need to convert it to the HSV color space. So let's just print that out too. You can see we've got the background pixels. So to find that area on the image, we're going to use the find contours function. And if you don't find any contours, we're just going to return. If we do find contours, we need to select the largest one. And we're just going to spin through each contour, get its area. And then if its area is larger than what we've already found, then we're going to assign it as the largest contour. Then we can get its bounding box and just draw this out onto the screen too. If we run that, and we see we have a bounding box around our context menu. Next, we need to select text inside this menu, so we're just going to select all the white pixels. So you can see we have all the white pixels there. We also need to detect the orange text, so we'll do that next. And before we print this out to the screen and run it, we're just going to combine them into a single image and print that out to the screen too. If we run it now, so you have white text and orange text and combined. So to actually extract the text from the image, we're going to use a library called Tesseract, and Tesseract prefers black text on a white background, so we're just going to use the bitwise not function to flip the pixels around. To actually extract the text, we're going to create a new method. And Tesseract prefers a real image saved to the hard drive rather than one in memory, so we're just going to save it as a temporary file. And let's create a list of items that we've detected. Now we can initialize the Tesseract engine, which takes a path to the test data folder, which contains all the training data. And we're going to load the image and load the page from the engine, and then get the iterator for the page. Now we can start the iterator, and we're just going to use a string builder to build the current line. So we're going to spin through each text block, spin through each paragraph inside each text block, spin through each text line inside each paragraph, and then spin through each word inside each text line. Now we've got each word, we can append it to the current line. And if it's the last word in the text line, then we can append that line to our list of items. And if it's the last text line in the paragraph, we can append that final menu item. Finally, we just need to delete that temporary file that we saved, and we can return our list of items. If we call that method now, we're just going to set a breakpoint as well so we can inspect it. So you can see we've got 6 menu items and it's extracted the text pretty well. Okay, we're just going to create a class to hold the menu item. And it's going to have a location and its text. And then we can use this to create a list of menu items that we've detected. Finally, we're going to stop debugging first. And then we're just going to assign to our list of menu items. We run that now. You can see we'll have a list of items and each one should have a location and the text. Okay, back to the killbot. So after we've clicked on right-clicked on the drop to bring up the context menu, we're just going to use our context menu detector. And if it can't find any items, then we'll return. And we'll check if we have a take bones option. And if we don't, we'll return as well. Then we're going to use our HUD detector from a previous video to get the first empty inventory slot. And we're going to click on our take bones menu item, and we're just going to wait until those bones appear in the inventory. Okay, now time to test. So you can see we click on a Chaos Druid and we wait until he dies. And then we can take his bones and before clicking on the next Chaos Druid. Now it's time to detect the other drops. So we've just picked up the bones, which means we're now standing on top of the drop, and the drop will be in the center of the screen. And to figure out how many drops we're going to take, we just use the existing context menu detector, and we see how many menu items start with take. Also, we need to -1 because we've already taken the bones. So we're going to spin through each drop, and we're going to right click it and then reuse our context menu detector. We're going to check we have some menu items, and if we don't, we return. Otherwise, we can left click on the first menu item, which will be to take the drop. Okay, let's run that. So we're going to kill a Chaos Druid and wait till he dies. Then we're going to take his bones and any other drops. Okay, I hope you liked this video. If you did, please hit the like button and leave any feedback in the comments. And if you want to see more videos, please subscribe.